My dear students of ICSE board, class 10. In this video, we shall complete the third part of the first chapter, force, center of gravity and the uniform circular motion. These two parts we shall cover today. Center of gravity is a point in a body where it may be inside the body, it may also be outside, that we shall discuss later on. But suppose this is a body and the weight. What is the weight? Weight is the force of attraction by the earth, means gravity, towards its center. So this is the body where the force is applied by the gravity and due to which we feel a weight. This weight can be considered at a point, means all the weights. This body, you know that not a single one, but it is made up of very small particles. These all particles have their own weight. This we can understand in this way. Suppose this is a body. This is made up of very small particles. So many small particles are there. Suppose this one has the weight W1, this is the weight W2, this is the weight W3, this is the weight W4. These all are the weight of the different particles of the body. But these all, if we add them, suppose we get W is the sum of all the weight W1 plus W2 plus W3 dot. So many. So this is the total weight. Where this weight lie, we have to find out, and that is the center of gravity. Where, that means this W, where it lies, that is the center of gravity. In this body, we see here that this weight is in this way, that means the anti-clockwise, clockwise. So many momentums are there, clockwise momentum, anti-clockwise momentum, and if this body is equilibrium, then this can be considered, suppose this point is the G, where the whole weight W means the sum of all the weight is here. The sum of all weight is here, and this means that the anti-clockwise momentum, clockwise momentum, this all becomes 0. That means where the sum of all the forces becomes 0. So this is the center of gravity, and we can consider that this is the point where all the weight of the different particles can be considered to concentrate here. Means the weight is actually here. When we say balance it from this point, the body will remain balanced. Suppose this one, if it is balanced here, that means its center of gravity is at this point. The center of gravity at this point. So this is balanced here. This is the center of gravity. So students, now from this explanation, detailed explanation, you can find out the definition of the center of gravity, that is the CG. What definition will you give? The center of gravity means the point where the algebraic sum of all the moments of the particles which constitutes the body is 0. Means algebraic sum of the moments of all the particles that constitutes the body is 0. It's anti-clockwise and clockwise moment, total sum is 0. That is the center of gravity. And in simple way to understand it, that what actually it is. What actually it is means a point where we can say that its weight is concentrated there. Distributed weight is concentrated at that point. That is called the center of gravity. Now the question arises that if we place a body at different places, will the center of gravity change? No. If you suppose take the body and you have taken in that way, in that way, in that way, so the center of gravity will change inside the body? No, it doesn't change. It may change, it depends upon the shape of the body. If you are changing the shape of the body, then the center of gravity will change. For example, suppose this is a rod, its center of gravity is here. And when we bend it to make a circle, this one is a rod, its center of gravity is here. If we bend it to make a circle, then its center of gravity will change and come out here at the geometric center of the circle, which is outside the body. That I was telling that we shall discuss later on. That center of gravity, it is not necessary that center of gravity will lie inside the body. It may lie outside the body also. This point, this center of gravity is not inside the body. But when it was like a rod, then the center of gravity was here. As soon as we have changed its shape, its center of gravity changes to this one. Now we can take the example of the different shape and find out the center of gravity where it lies. If it is a cylinder, where will the center of gravity lie? Just in the center, geometric center of the cylinder. Solid one, it must be solid. If it is a triangular shape, triangle, suppose of any shape, then where will the center of gravity lie? It lies on the intersection of the median. Midpoint, midpoint, midpoint. Median, we have one drawn, second median, then third median. So this point will be the center of gravity. This will be the center of gravity. If we take parallelogram, where will the center of gravity lie? At the point of intersection of the diagonal. This is the center of gravity. Simple way to say that from which point will you suspend that the body will just be horizontal. The body will be horizontal. That point is the center of gravity. So if we tie a thread from angular point to the midpoint, angular point to the midpoint where they meet, if you tie a thread and hang it, suspend it, you will see that the triangle is just like a horizontal plane. So this is the point from where if you tie it, it will be horizontal. If we take a cone, if this cone is hollow, and if it is solid, now you can say that the shape is same, then why the center of gravity will change? The center of gravity, what I told you, the center of gravity actually is the weight of the body that we can consider that at that point the weight is. So when it is hollow, it is lighter and its weight is distributed in different way. And when it is solid, hollow, then the weight, this weight mainly the center of gravity lies very low, that means towards the center towards the earth. So here this is the height, it will be at the 1/3, and if it is solid, this portion is heavier, this portion is lighter, so its center of gravity means more heavy. Where this is more heavy? Here it will be at the 1/4 of the height. So in hollow, the center of gravity will lie at the 1/3 of its height, vertical height, and if it is solid, it lie at the 1/4 of the vertical height. This way we shall get the center of gravity of the different shape. If it is circle, I told you that circle, in a circle, it is at the geometric center. If it is a circular disc, that means the solid, circular disc, then the center of gravity also at the geometric center. In a circle, this is only a wire or rod, and this is hollow part. So center of gravity is outside the body, but here the center of gravity is in the body, but at the geometric center of the body. In that way, we can find out the center of gravity in the different way. But if a body is of irregular shape, where the geometric center cannot be found out, then how can we find out the center of gravity? To get a center of gravity of a body that is of the different means irregular shape. So I am drawing here. Suppose a body of the different shape, irregular shape. This is the body of irregular shape. How can we find out the center of gravity? We can find the center of gravity. Make 3 holes. Suppose here at the end here we make hole here, we make hole here, and from this hole through a wire, thin wire or strong string, just suspend it. When it will suspend it and come to stand still, when it comes stand, then a line through this point, vertical line through this point, draw a line. Now again repeat the same thing, just by changing this one. Take this one and suspend it. Again, this will be in that way, a line will be there, and again repeat using this one. When we tie a thread from here and suspend it, now it moves to this directions and it is moving in that way. So the point of intersection where these lines, vertical lines, are intersecting, that will be the center of gravity. Now a question for your short question, MCQ question, or a 1 marks question may be asked, that the line, that vertical line which we have drawn here, when we have suspended it with a thread at any hole, suppose hole number A, hole B, hole C, when we suspend it from here, then the line which we have drawn, just when it comes, stops its oscillation and comes to stand, the line, what is the name of this line that we have drawn? This may be there in your MCQ question. This line is called plumb line. Plumb line. This line has a special name, plumb line. So the center of gravity is the point of intersection of the at least 3 plumb line. When you take 3 plumb line, the center of gravity is there. For a stable equilibrium, where is the place of center of gravity? So for a stable equilibrium, that means the body when it is stable, it has come stand still, then the center of gravity is the point as low as possible to the base, but above the base it will lie. And it is the lowest point in that one. This one, where it comes down, when we put it here, it is unstable and put down. When you put here, it will put. But when it comes here, now it is standing, and it is now no falling. Why? Because the center of gravity has come to the lowest possible lowest point to the base here. But when we are putting here, the center of gravity comes at the high level, higher than when it is placing in this horizontal way. So when the center of gravity is the lowest possible point from the base, it will be stable equilibrium. It is not stable, it will fall down. But now there is no chance to fall. It will roll here, but now no fall. This is the about the center of gravity, you understand. Next topic is uniform circular motion. So uniform circular motion, that means when a body is rotating. When a body is rotating, this is the uniform circular motion. When it is rotating at a constant speed, then that is the uniform circular motion. Okay. But now when a body is rotating at a constant speed, then what are the different forces acting on it? Okay. Then first, there is 2 kind of motion, velocity. We can take velocity and speed. Speed is constant. Speed is constant when a body is moving in a circular path with a constant speed. For example, the earth. The earth is moving around the sun in a circular path. It is not fully circular, but suppose consider it is circular path. In a circular path, it is moving and its speed is constant. That is why the year and all the things, time comes at a regular interval. That means the speed is same. But when it is moving at the constant speed, but in a circular path, its direction is continually changing. What does it mean? It means that its velocity is accelerated. Its velocity is not uniform. It is accelerated velocity. आई बात समझ में? वेलोसिटी और स्पीड के बारे में मालूम है ना कि नहीं? वेलोसिटी को हम लोग क्या बोलते हैं? उसमें डायरेक्शन रहता है. वेलोसिटी और स्पीड का ऐसे सिंपल उसमें क्या कहते हैं कि रेट ऑफ चेंज ऑफ डिस्टेंस और डिस्प्लेसमेंट. डिस्प्लेसमेंट जैसे वर्ड आए तो उसमें क्या हो गया? एक डायरेक्शन होगी. दिस इज डायरेक्शन. हियर द डायरेक्शन इज चेंजिंग दो द मैग्नीट्यूड इज सेम. The change of magnitude of the distance is same. That means the speed is same, but the direction is changing. It means that there is a non-uniform velocity and it is accelerated one. Now students, what rotation and revolution, two words are there. Rotation means at a single point it is rotating, and revolution means to a false point in the middle some particle is moving around it. In revolutional motion is the circular motion. Revolutional motion is the uniform circular motion. But if we are taking the rotational motion, in a rotational motion, as we have said you that a body may be considered of the made up of very different particles. When a body is revolving there at the center, and this body is revolving in a circular path. So this is the revolution. And if this body at this center is now moving, so this is rotation. But in this rotation, you see that though it is rotating, but this particle from the center is at a distance, and this is moving in that way. That means this particle has the revolutionary motion. So this particle is moving uniformly in a circular path. So every particles is revolving towards the geometric center of this one. And if the whole body be taken as a unit one, then it is revolving with respect to a center. Uniform circular motion is the motion of a body on a circular path with respect to a center. And if its velocity is constant, then it is uniform circular motion. So speed is constant, but the velocity is always changing. It is accelerated. Okay. Now we can have the question that if it is moving in a circular path, then I've told you that though the speed is constant, but the direction is changing. So what will be the direction? If suppose it has reached here, what is the direction? Velocity has a definite directions, not the changing directions. So this will be the just tangent. Draw a tangent to this circular path. So this is the direction of the velocity of this point here. And if it has reached here, the tangent to this circle, tangent here, tangent at this point is the direction. So to find out the direction of the body moving in a circular path will be the tangent at that point where we want to find out the direction of the body. Wherever you want to know the direction of the body, the direction of the velocity or direction of the body, then you draw a tangent there that will give you the direction of the body. ये तुम्हें डायरेक्शन बता देगा जैसे ही टेंजेंट ड्रॉ करोगे, ये हो जाएगा उसका डायरेक्शन। ठीक है, अब ये जब मूव कर रहा है तो डायरेक्शन किधर जा रहा है, बाहर की तरफ जा रहा है। लेकिन ये सर्कुलर मोशन होने का रीजन क्या है, व्हाट इज द रीजन फॉर द सर्कुलर मोशन? ये रीजन है कि इसमें एक फोर्स जो इस बॉडी को अकॉर्डिंग टू न्यूटन्स लॉ, ये बॉडी अगर मूव कर रहा है तो इट विल गो इन वन डायरेक्शन ओनली अंटिल ए फोर्स इज अप्लाइड टू चेंज इस डायरेक्शन। जब तक एक फोर्स अप्लाई नहीं करेंगे इसके डायरेक्शन को चेंज करने के लिए, ये तो एक ही डायरेक्शन में जाना चाहिए। तो क्यों इसका सर्कुलर मोशन है, व्हाई इज द सर्कुलर मोशन? इट मींस दैट सम फोर्स इज एक्टिंग ऑन इट। ये बॉडी जाना चाह रहा है इधर, दिस बॉडी वांट्स टू मूव इन दैट वे बट इट हैज टर्न्स टू दिस, दैट मींस समवन इज देयर हु इज attracting it towards this point, from this point, from this point, from this point, from this point. So from each point, a force is acting towards the center of the path, center of its path. So that direction is towards the center, means inside. This force is known as the centripetal force. Centripetal force. So what is centripetal force? Centripetal force, and it always create only in a circular motion. तो सर्कुलर मोशन में ही ये होगा। अगर लीनियर मोशन है, गाड़ी अगर दौड़ रही है सड़क पर, तो वहां थोड़ा ना कोई फोर्स उसको अंदर खींचेगा तो उसका रास्ता घूम जाएगा। तो ये उसका पाथ जो मूव कर रहा है इधर, हर बार तो जाना चाहिए इधर, यहाँ है तो उसका डायरेक्शन इधर है, लेकिन हम देख रहे हैं कि घूम जा रहा है। घूमने का मतलब है कि उसको कोई खींच रहा है। ये फोर्स, अब तो जैसे मान लो इसमें एक हम लोग सूता बांध दिए और एक बॉडी को लेकर झुला दिए और ऐसे घुमा रहे हैं, तो सूता के माध्यम से थ्रू द थ्रेड, है ना, ये इनसाइड की तरफ जो है टुवर्ड द सेंटर एक फोर्स एक्ट कर रहा है, यही है सेंटीमीटर फोर्स। अब जैसे कि अर्थ है, तो अर्थ को सन तो सूता से बांध के रखा नहीं है किसी डोरी से, वहां क्या है, ग्रेविटेशनल फोर्स है, लेकिन एक फोर्स मस्ट वर्क टुवर्ड्स द सेंटर ऑफ द पाथ, तो वो हो गया उसका सेंटीमीटर फोर्स। और जब भी ये सेंटीमीटर फोर्स यहाँ पे बन रहा है, एक जो है इमेजिनरी फोर्स भी क्रिएट हो रहा है, मतलब ये रियल फोर्स है। ये हो गया, हम लोग क्या बोलेंगे कि सेंटीमीटर फोर्स एक रियल फोर्स है जो वास्तव में उसके डायरेक्शन को जा रहा था किसी एक डायरेक्शन में, अकॉर्डिंग टू न्यूटन्स लॉ इट मस्ट मूव इन वन डायरेक्शन ओनली, लेकिन ये घूम गया, इट टर्न टू अनदर डायरेक्शन, इट मींस दैट a force is acting on it and that force is the centripetal force. So centripetal force is the real force. But जैसे ही मान लो ये सूता यहाँ से टूट गया, ये हम इसको घुमा रहे हैं और इसमें तो बांधा हुआ है, सूता से बांध घूम रहा है, जैसे ही टूटेगा ये छिटक करके दूर जिस डायरेक्शन में जहां से है टेंजेंट वाले डायरेक्शन में सीधा निकल जाएगा, तो ये अपने डायरेक्शन में चला जाएगा। तो ये उधर लेकर के जो गया, दैट मींस अवे द सेंटर। ये जो फोर्स है जो इसको टूट जाने के बाद में इसको जो लेकर के चला जा रहा है, ये टुवर्ड्स द सेंटर नहीं हो रहा, ये अवे द सेंटर हो रहा है। जो अवे द सेंटर है उसको लोग कहते हैं सेंट्रीफ्यूजल फोर्स, जो इसको बाहर की तरफ, इसको जो फोर्स है किस तरफ ले जा रहा है, एक फोर्स बाहर की तरफ ले जा रहा है, ये हो गया हम लोग का सेंट्रीफ्यूजल फोर्स। सेंट्रीफ्यूजल फोर्स, तो सेंट्रीफ्यूजल फोर्स। अब एक क्वेश्चन है, तब क्या ये एक्शन रिएक्शन है? न्यूटन्स के थर्ड लॉ में है कि जब हम लोग कहीं पे एक्शन होता है तो उसका एक रिएक्शन भी होता है ना, इक्वल एंड इन अपोजिट डायरेक्शन। सो इफ दिस फोर्स, व्हेन द सेंटीमीटर फोर्स हैज बीन क्रिएटेड, centrifugal force is also created and just in the opposite direction and equal in amount also, in opposite direction and equal in amount also, that is why it is not changing its path। अगर ये सेंटीमीटर फोर्स ज्यादा हो गया तो ये इस तरफ आने लगेगा, जैसे अगर सूता इसमें घूम रहा है तो ये क्या, इससे लपेटते लपेटते ये पास में आ जाएगा, ये ना, और टूट गया तो बाहर चला जाएगा। तो ये ना अंदर जा रहा है और ना बाहर जा रहा है, एक जगह पे घूम रहा है, इसका मतलब कि दोनों फोर्स सेम है। तो ये एक्शन रिएक्शन लग तो रहा है, ये भी नहीं है, क्यों नहीं है, अपोजिट डायरेक्शन में है, सेंटीमीटर फोर्स के कारण बना वो इक्वल इन अमाउंट है, फिर भी नहीं है भाई, क्यों? चला से याद करो कि एक्शन रिएक्शन किस पे होता है, एक्शन एंड रिएक्शन डजंट टेक प्लेस ऑन द सेम ऑब्जेक्ट। सेम, जैसे बॉल को अगर हम दीवार पर फेंके या बैट में फेंके, तो बॉल ने एक्शन किया दीवार पर, उधर से टकरा करके आया तो दीवार ने रिएक्शन किया बॉल पर, तो एक्शन हुआ बॉल पे या बैट पे और रिएक्शन हुआ बॉल में। तो यहां एक्शन रिएक्शन टू डिफरेंट ऑब्जेक्ट पे नहीं हो रहा है, इसलिए दैट इज द रीजन this is not the reaction force, because the two forces are acting on the same body. Action and reaction take place on two different objects. One object, when act on a body, that body react on that object. So two different objects are there on which action and reaction take place. But here the action is also on the same object and reaction is also on the same object. So this is not the action and reaction force. Though it is opposite, though it is equal in amount, but it is not the reaction force. This is a fictitious force, एक काल्पनिक है, क्योंकि ये बनने के कारण ही ऐसा हुआ है. एक मोशन, सर्कुलर मोशन में जो सेंट्रीपिटल फोर्स है जो टुवर्ड्स द सेंटर है, तो इसका अपोजिट एक फोर्स, जैसे ये टूटेगा, जैसे फोर्स हटेगा, ये फ्री हो जाएगा. एंड एज सुन एज द ऑब्जेक्ट बी फ्री फ्रॉम द सेंट्रीपिटल फोर्स, इट मूव डायरेक्टली टुवर्ड्स द इट्स ओन डायरेक्शन एंड अवे फ्रॉम द center. So that is the centrifugal force, and that force is the fictitious one. It is created after its motion starts. Okay. So where do we see the centripetal centrifugal? This centripetal centrifugal force make the object move in circular path and at a constant path, a constant orbit. Okay. This we see in the electrons, where the electrons are moving around the nucleus in a constant orbit. Earth is moving around the sun in a constant orbit. In the same way, other planets are also and moving around the sun. Satellites are moving around the Earth or the planets. So these all are the examples and the results of the centripetal and centrifugal force. So these topics, the two topics we have completed today. Now we shall start in the next video, new chapter. Okay, thank you.